The vectors P and Q are defined as P is equal to 12 and -5, and Q is equal to -6 and 5. Calculate the column vector P plus 2Q. And so we have P plus 2Q. What is P? Well, P is 12 and -5. What is 2Q? Well, that's going to be 2 times Q, 2 times this vector. And so we have 12 and -5, and we have 2 times Q, and we know that Q is -6 and 5. And so what are we going to do? Well, the first thing we're going to do is we're going to multiply. So we're going to take 2 and multiply it by -6. We take 2 and multiply it by 5. And so we have 2 times -6, and 2 times -6 is -12. Then we say 2 times 5, and 2 times 5 is 10. So we have 12 and -5 plus 12 and 10. And so we add, we say 12 plus -12, and 12 plus -12 is 0. Then we say -5 plus 10, and -5 plus 10 is definitely +5. And so we have P plus 2Q that's equal to 0 and 5. So the column vector P plus 2Q is equal to 0, 5. Next, we have to calculate the value of M when MP is equal to MQ. And so here we have, if MP is equal to MQ, then the following holds. Then that means that MP, so we replace P with our column vector, is equal to MQ, all right? And so we know that Q is this column vector, and we can multiply this M by each term in this vector. So we have M times 12, which is 12M. We have M times -5, which is -5M. We have M times -6, which is -6M. And we have M times 5, which is 5M. Now, if two vectors are equal, that means that corresponding entries or corresponding entries or corresponding components are equal. And so that means that it says since the two vectors are equal, it follows that their corresponding entries are also equal, which means that 12M is equal to -6M. And it also means that -5M is equal to 5M. And so what we can do is we can take this -6M, send it over the equal sign. It was a negative, but when we send it over, it becomes a positive. So we have 12M plus 6M is equal to 0. And so we have 12M plus 6M is equal to 0. 12 plus 6 is equal to 18. So we have 18M is equal to 0. We divide both sides of this equation by 18. This cancels with this, so we get that M is equal to 0 divided by 18. Again, M is equal to 0 divided by 18. And 0 divided by 18 is 0. So M is equal to 0. Let's check about on this side. So we send so it's a +5. We send it over the equal sign. Let me show that. So in this case, we sent the -6M over. And in this case, we sent the 5M over. All right. And so what we have, well, we have -5M. This was a +5M, but when we send it over the equal sign, it becomes -5M. So we have -5M minus 5M is equal to 0. We have a -5M minus 5M. That's going to be equal to -10M. We divide both sides by -10. This cancels with that, so we get that M is equal to 0 divided by -10. And 0 divided by -10 is simply 0. So if MP is equal to MQ, then that means that the value of M is going to be 0. So M is equal to 0. Okay, now they want us to calculate the magnitude of P. Now in general, if we have a vector that is a column vector with two entries or two components, we're going to take the first component, square it, take the second component, square it, add those two answers, and then take the square root of the sum. And so we have P, and P is 12 and -5. So we take the first component, 12, and we square it. We take the second component, -5, and we square it. And so what is 12 squared? Well, 12 squared is 144. What is 5 squared? What is -5 squared? -5 squared is -5 times -5, which is 25. And then we say, okay, well, what is 144 plus 25? Well, 144 plus 25 is 169. And so we have that the magnitude of P is equal to the square root of 169. And what is the square root of 169? Well, the square root of 169 is 13. So that means that the magnitude of P is equal to 13. Okay, and that brings us to the end of this question. I'll see you in the next video.